The Hawaiian water filter, a water filter built to optimize flow rates and visual appeal while removing dye from even the darkest of liquids. Designing, testing, iterating, and retesting were performed in order to ensure the success of this product and to therefore ensure the happiness of its users. The Hawaiian skirt on this filter gives the user a sense of happiness as they imagine themselves sitting on a beach in Hawaii drinking water fresh from the filtration of the Hawaiian filter. This seemingly complex water filter was built using only 3 parts: a water bottle top, the body of the water bottle, and a styrofoam cup. The top of this bottle is flipped over and placed neck down into the body of the bottle, and this combination is placed into the styrofoam cup. The openings at this bottom of the bottle allow the water to flow through the entirety of the filter. Both the top and the body of the water bottle were used to hold the media and direct the flow of the water through the filter, and the styrofoam cup was used to collect the filtered water to use for testing or drinking. Inside these parts were 2 types of media, coarse sand and activated charcoal, both of which have large surface areas and small pores, which are 2 properties that are beneficial for removing dye. In addition to these parts, the Hawaiian filter also contains both fine and coarse filter paper in order to remove more dye and help layer the media. This design helps the device perform at a high level and helps to remove much of the dye from this previously dark liquid.
The device performed really well, as we talked about. For the baseline, we started with 102.1, but after filtering, it was only 8.275. That's 92% removed dye. The flow rate of the filter was 10 milliliters in 69 seconds, which was very quick. As you can see in the picture at the bottom, there's on the left, the dye before it was filtered and the dye after. And there's a large difference in the color as much of it was removed. In the graph, you can see the different iterations we had. The original design did not work very well. And our first iteration removed more dye, but much of it was still left. However, after our last iteration, we were able to remove much of the dye.
Even though we worked hard to create a good filter, we also attempted to minimize cost. The final cost of the device was $188.50 out of the maximum $300. The majority of the cost came from the filter paper, which cost $15 per piece, the soda bottle, which cost $20, and the activated charcoal, which cost $35. This total takes into account the iterations that we performed.
Our first design tried to utilize the stretch element of blank is the best, with our only material being used being sand. This, however, did not turn out very well, as the filtered liquid came back more or less the same contamination that it came in with. For our first design, we had it set up mostly as we had our final design with the cut water bottle and the top flipped over, with this helping to guide as we poured the contaminated water into our filter, with a coarse filter at the bottom of this bottle with just sand in the bottom. Our first iteration helped to improve upon our filtration by adding activated charcoal into coarse filter paper at the bottom of the bottle and moving the coarse filter paper with the sand to the top part of the bottle near the neck. This improved things, but we could see that we could definitely make some good improvements. Our second and final iteration is what you see here, which was an addition of activated charcoal below the sand in the top of the bottle, and a very stylish and aesthetically pleasing green felt hula skirt with 3 pom-poms and a single eye. Some possible future improvements our design may hold could be to add some more layers of the activated charcoal, given that that seemed to be one of the most effective media that we used, and possibly to 3D print some sort of apparatus that could hold the cuvette and make sure that the minimum amount of light would enter so that our readings would be more accurate.